So here what I have is I have a completely fictitious clinician's note and a prompt telling the LLM to please put this into ICD-10 codes in a useful CSV format so that I can do data things with. So that's fee 3 doing that. And you'll notice that I'm using something called PowerShell here. So Windows PowerShell is a command console available in Windows with some additional functionality. And in particular, what it's letting me do is use this cat command to pipe a text file directly into this command console. So I'm actually having it look at a specific file. And the Podium computer here has 8 gigabytes of RAM, which 20 years ago would have been a reasonable amount of RAM on a computer. It's not a very large amount of memory by modern standards, but it still can actually run a couple of these advanced large language models that are built for remote deployment. It doesn't do them very quickly, which is why we'll kind of just go and get back to that later, and we'll see what Gemma made of that note later. But it's quite possible to run large language models locally, particularly with Ollama, which is what I'm going to generally recommend for use here. The next question, why would you want to run an LLM locally? And I feel like there's a few good reasons why you would run an LLM locally. What you're giving up is you're giving up the full state-of-the-art, cutting-edge level of performance. So you're not going to get quite as good results as quickly running fee 3 on your local machine as you would querying the latest version of ChatGPT up on the cloud. However, you may not want to send all of your data to OpenAI for them to add it to their training set. It's certainly not something you can do with private or sensitive data. You can also exercise a lot of control over what exactly the model is told to do in terms of its prompt structure, response format, even particular fine tunings of large language models for specialized tasks. You can control that all very well if you do it locally. This is just a quick little overview of what I mean when I'm thinking about a local LLM. So I don't mean that you have something on your computer that's running. I mean, it definitely does not go out there and talk to the internet while you're using it. It does not throw your data across the cloud. It does only what you tell it to do. And you notice I'm using this phrase, in the box. You want to put your LLM in a box. This is a practice known as containerization. You want to make sure that when you're trying to work with sensitive and private data, that you have basic security measures in place that ensure that the program that you're using isn't doing anything it's not supposed to be doing. Now, you will actually run into, as this space is diversifying in terms of the available offerings, large language model is no longer a useful term because large language model includes a 2 GB model, large language model includes a 70 GB model. You have large language models that you cannot possibly run on a normal high-end gaming machine. So some of the very large language models are quite different in scale from some of these smaller things that are also called large language models. So now we're starting to call these portable language models with similar architecture that are way bigger than anything anybody was working with 10 years ago. These are now sometimes referred to as SLMs, small language models. Just for your reference, when you're reading about the very fast-moving field that we've got here. If you've worked with LLMs before, you've probably heard of Hugging Face. This is an organization that does a lot of research with LLMs. They're responsible for the Python Transformers library. They also host a repository of large language models and data sets. The Transformers library has functionality both for remote LLM work and local LLM work. By default, most of what you do in Hugging Face, the behavior will look like it downloads the model. If you don't have it already, it'll cache it somewhere in case you want to use it again. The Hugging Face Transformers library itself, if you want to get away from it, I have bad news for you. Many, possibly most of the Python libraries that have been developed to deal with large language models use Hugging Face as a dependency. So I would strongly recommend getting comfortable with the Hugging Face library. And now I want to talk about something that has come up in the context of Hugging Face, which is security issues. So there have been, and probably still are, malicious models up on the Hugging Face model repository. And the reason that Hugging Face, you can't just download random things from Hugging Face and expect your computer to remain secure, is not a problem that is unique to Hugging Face. It's not particular to the Hugging Face Transformer library. So as of 2023, last year, PyTorch was probably the most popular library for working with machine learning as related to large language models. And PyTorch uses as its standard object serialization format something known as a pickle. And it turns out that this core Python library that lots of people use, this serialization format that lots of people use because it's very efficient for storing these complex models, can execute arbitrary code. Or in layman's terms, they can put a program in it that will do whatever. Okay. So, and in particular, one of the things that's been observed is people putting malicious pickles up on Hugging Face that will open up a remote shell with admin access on your computer, which is the last thing that you want. Even if it's your personal gaming computer rather than a sensitive work machine, you don't really want that. So an alternative format for storing models more safely has been recently developed as this pickle fiasco has become more widely known, and that's safe tensors. But even so, just because safe tensors has not been shown to have the same sort of vulnerabilities just be generally careful about making sure you're using a model of known provenance. You want to just help push future problems out of the way, get your data somewhere you know about, get your model somewhere you know about, pay attention to the provenance of models and data. Now, I have a strong recommendation overall related to security, which is, in general, if you're going to be running local LLMs, run open source stuff. And the reason for this, and we'll circle back to this later, there's a fundamental conflict of interest in the LLM world, the language model world, between providers and customers. Customers have data that they would like to keep private. Language model providers really would like high quality representative data, like the data that their customers are using. And this means that a lot of these companies would like to get their hands on the data that's being fed into their LLMs as training data to use for their LLMs. It's a basic fundamental conflict of interest. So the question becomes, how much do you trust the LLM companies in terms of, are they going to stick by those promises of privacy? We had a recent little fiasco where Slack just said, oh, by the way, we're going to use your Slack message history for training our language models now, unless you opt out. So you may have heard that on the news this week, and lots of people are very upset about that, because there's a lot of stuff that people had on Slack and their message history that's a very private information. So now, open source is not a magic bullet. A program, a model being open source does not mean it's perfectly secure. It does not mean it doesn't have any malicious code in here. Security in the open source world depends on scrutiny. And this is why I offer this sort of refined recommendation. When you're looking at your language models, pick an open source model from one of the big boys. Because Microsoft cannot release a new cutting edge large language model without thousands of people scrutinizing that thing. Now, it might be hard for any one person to go through the code line by line, but there are a lot of people very interested in exactly what goes into the guts of each new major open source model released by one of the big players. So that's what I'll talk about next, is I'll talking about the major players in the area and what they have on offer for this local LLM possibility. So first I'm going to talk about OpenAI a little bit, because they're the most famous player in the space. They sort of set the tone of the conversation with ChatGPT, made a really big splash. In spite of their name, OpenAI is mainly about closed proprietary LLMs. They're very secretive. Their first major GPT release that got some attention, not the same attention as GPT-3. GPT-2 is the only open source model of note that I'm aware of from OpenAI. So now, there are some sort of spin-off projects from OpenAI that are related to GPT-2, or have a lot of people who used to work from OpenAI working on them. So Eleuther AI has a family of open source GPT-like models that are built on top of that original GPT-2 framework developed from there, GPT-J. So there's a whole sequence from Eleuther AI that's closely related to that. There's also another entirely closed, basically I would say spin-off ex-OpenAI people in Anthropic, but they're entirely also on a closed model as far as I can tell. Microsoft. Microsoft is definitely a big player. Copilot is their flagship AI. It is not useful for this. It is a closed source one. It may very well be something that will be useful in some way to people at UNC, depending upon the contracting and licensing arrangements that UNC comes up with. But what I'd like to call attention to is the Phi model. And in particular, Phi 3 Mini is a very small, very efficient AI model. So if you go over here, the reason why that's the model that I ran for my first example the first time. And the reason why I ran it is this computer does not have very much memory, does not have very much CPU, but it can still run Phi 3 okay. It can do an okay job with Phi 3. So I had a typo. So in this case, on this computer, you're going to wait for any model at all. But if you're waiting for a larger model, it will take longer. And voila, it's already going. So you'll notice it's not super, super fast. This is about the kind of speed you can expect from a potato, which is to say this console machine. Your personal laptop is probably a little bit faster. If you have a work laptop, I have a work laptop. It is faster than this. And it's not a particularly impressive work laptop. Another model that's out of Microsoft, or actually model family, Phi is a model family, 3 Mini is the one that's of special interest right now. Orca, in the case of Orca, Orca 2 is of special interest. It's a slightly more specialized model, also built to be portable. And Microsoft also had this partnership with an outfit called Mistral AI. And Mistral, in turn, is mainly populated by ex-Meta and ex-Google people, or at least that's kind of how it started out. So this is a team they spun off. They did this partnership with Microsoft, and they built really what was the first of these SLMs that was designed for portable use, which is the Mistral AI now comes in several flavors of slightly different sizes. It's open source, it's fairly widely used, it's fairly widely scrutinized. I would keep it on the list. Mistral has branched off into the closed model world where the money is, now that they have their flagship attracting attention. So they have their closed source versions of those that they're actively working on. Google is definitely a big boy, right? So their flagship is Gemini, that's closed and proprietary. It replaces Bard, which was also closed and proprietary. Google also had a number of early large language models before they started to attract the kind of attention that ChatGPT-3 came before ChatGPT-3. BERT and T5. And these are interesting because they are built on a different architecture than ChatGPT. They are not strictly chat AIs. They're designed for other tasks. So when you're looking at specialized tasks that you use large language models for, you may work with some things in the BERT and T5 family, even if those are older models. People have been specializing and paying a lot of attention to this chat functionality. These are designed to do other types of tasks. And then Google does have its very recent SLM called Gemma. So this is a small open source language model, much like Phi3 Mini, much like Mistral. And now Meta, formerly Facebook, they actually have a flagship model called Llama, and the Llama model family is open source. And it comes in very different sizes, so you can get a smaller Llama model or a bigger Llama model. But the fact that unlike the other players in the area, I would say Meta is the biggest outfit in this domain that is focusing their efforts on their flagship being open source. And that might be because they were later to the game. It might be because they have a different monetization strategy in mind. I don't know why, but it's a good thing because Llama 3 is a pretty powerful model. They also have an older one that you might find if you look around called OPT. This was designed as a response to GPT-3. It's a little older, a little, I would just say outdated. So I'm bringing that up because you'll run across it if you start looking for, hey, I'm looking for models from Meta, Google, Microsoft, so on and so forth. That's an older model. Just use Llama. And that's sort of the recap here. We have, I would say currently there's about 5 models that I would just easily recommend you use because they are relatively efficient, cutting edge chat models that are not super huge, or at least have small versions of them in the case of Llama. BERT and T5 are not totally obsolete for what they're supposed to do. So now I'm going to go through the logistics of trying to run models locally. And I mentioned you kind of want to put these things in a box for security reasons. The most powerful method is a virtual machine. You can use a Docker container. Now, there's also this little thing where most of these models are optimized for GPU. Llama C++ is designed to run it on CPU, which is a major consideration for portability. And that means that you have several major options that are based on leveraging Llama C++ and are boxes to put your LLM into. So Ollama, Llama-File, GPT-4All, I'll talk about all 3 of those. If you're an Apple or iPhone user, yes, you can run this on your iPhone. LLM Farm is out there. I have no idea how good it is. I don't have an iPhone. I wasn't able to test it. NVIDIA has a specialized one called ChatRTX. So if you have a machine with an NVIDIA GPU, I have the feeling this might be the most thoroughly optimized for NVIDIA GPU performance. Just putting it out there, NVIDIA probably knows how to use their chips. And then if you're an Android user, you can try out MLC LLM, which is a multi-platform container. Now, virtual machines are the correct choice from the perspective of maximum security. So when you're doing highly secure environment stuff, you're going to work on a virtual machine. I am sometimes working on a virtual machine. My father, back when before he retired, he did lots of telecom stuff, and they did virtual machines on everything because they needed to make sure they had everything totally locked down. Virtual machines require a little bit of setup. They're highly flexible. if you're running a virtual machine specifically for the purpose of running an LLM on it, so a virtual machine runs an operating system within an operating system. Pick a lightweight Linux distribution. Save yourself the wasted resources if you're not doing other things with it. Lightweight Linux OS, just run the LLM inside of that virtual machine, and that'll get the most bang for your buck in the virtual machine world. Docker is basically the gold standard for running Python securely. This is what most people rely on most of the time in this kind of space. So this is a little less secure than the virtual machine environment. It is possible to escape a Docker container. It's also worth noting that because Docker has been so standard for so long, the exploits are kind of out there in the black hat world. So people can expect that, oh, I'm releasing a model. Well, lots of people will put it in a Docker container using the current version of Docker. So target architecture for the exploit is known. It still is good enough for most people. It also gets used in a number of these other pre-built solutions as a layer. So Docker is actually running under the hood in a lot of these other situations. And you could also run these inside of Docker as well. So you could run Ollama inside Docker, and then Ollama is running another Docker inside of it. It happens. And speaking of Ollama, let's talk about Ollama. So that's the one that I demonstrated. This is quite popular. It relies on the Llama C++ library, and it uses Docker under the hood. Installation does not require admin permissions. I did not ask IT to install Llama on this Podium computer. I just went and did it. It installs on a basic user level. It doesn't need admin permissions at all on Windows to install. It supports pretty much all the major models out of the box. You can also use custom models that you downloaded. Or more likely, and I kind of recommend it this way, models where you've taken one of these standard models and you've done personally some fine tuning on it for your data use case. Because that is something that you can do quite well with, say, Hugging Face, is you can fine tune existing models to make sure that those models are working well trained for the type of data that you're using with them. Another option, Llama file. This comes from Mozilla, by the way. This is kind of the maximum portability solution. It sticks the entire everything all into one big executable file. So you can just stick that file on a USB stick, run it. It's not a great fit for Windows, by the way. Maybe reflecting Mozilla's position in the open source ecosystem. Windows has a file size limit on executables. So you can run the very smallest models on Windows in an executable, but not sort of the medium-sized ones. Another thing that Windows does is when it has some random large executable file that the user stuck on a USB stick or downloaded and renamed, it treats this thing as a high security risk. So even the small ones, you cannot run them on a typical Windows install without admin permission, because every red flag in the world from Windows will go off. And I guess Microsoft doesn't necessarily like Mozilla enough to fix that. Now, it does support all the major models. It seems like a perfectly good option if you are not a Windows user. Now I'm going to talk about another one that I also installed on this machine, GPT for All. And you can actually have a look at it here. So it's got, Olama, I was using Olama. From a console. I was using it from Windows PowerShell. I was running specific commands on it. This one has it all in a nice, friendly graphic user interface. And it'll eventually spit out text, but I'll tab back over to my slide here about it. It is open source. I would recommend some caution when using this. So when you first set it up, there's a couple of scroll through checkbox stuff to go through at the start. And by default, this will launch all your data across the cloud to Nomic AI. Remember that conflict of interest I mentioned earlier? Nomic AI would love to have more training data. And by default, it will send it. So you have to make sure if you want to actually use this privately that you select the correct options. It does support the use of remote models. So generally speaking, if you're trying to do something that asks for an API key, it does mean that your data is going sailing across the cloud. So it does theoretically support custom models. In practice, actually getting a custom model into it is not trivial, and I don't want to spend the time to explain how to do it. The end verdict is I don't really recommend this. At least not for the kind of use case that I'm thinking about, where you do care about that privacy and security and flexibility. So it's scoring low on those. It is convenient. And if you want to install a chatbot for your kids to talk to on their machine, this might be a good choice. So Olama is my #1 recommendation. And the primary way that you're going to customize how models work is via the model file. And you can find lots of model files available as examples on Olama Hub. You can inspect model files within the PowerShell. So I can actually go and say, hey, Olama, show. Boom, I am suddenly treated to a bunch of legalese from Microsoft. But also, I'm treated to a couple of things which I'm not sure that they're necessarily super visible here. But you can see it has a response template in it, which you can adjust depending upon what you want your input-output dialog to look like. It has some parameters that you can modify. And then, of course, there's all this legalese at the end of the text file. But these model files will let you set a base system prompt, which you can set either with the system key or with message then system. You can also put in example messages for user and assistant to help show what kind of input you expect to put into it and what kind of output stylistically you want it to put out. And those are literally just write down example lines of output and input that you expect, and it will help the model work better for that use case. The template stuff is a little bit trickier. There's a whole template formatting system. You have to dig into the docs to get that. There's an adapter argument that lets you use a LoRa fine-tuning adapter, which is sort of an extra layer to stick on the end of the model without actually retraining the underlying model. And then you have a bunch of parameters that you can adjust. The one that I'm going to single out here is temperature. So people want a fun, happy chatbot to play with that tells them unexpected things. I want a chatbot to split out ICD-10 codes. These are not the same. If you look back at this output that we have for the ICD-10 codes, I'll scroll up. It is extremely likely that some of these ICD codes do not exist because I'm running a default high temperature model. And high temperatures tells the model, use a little randomization, get a little creative, make it look like it's there, but don't just repeat what's in the training data. Oh, I want real ICD-10 codes. I should turn the temperature all the way down. Because then it will start using actual ICD-10 codes that it actually saw in its training set. Another thing to pay attention to on a similar note, seed. If you're doing actual serious scientific work and you're trying to compare notes with somebody else, you need to have the same random seed in place. That will get you the same results. If you don't set the seed, it'll pull it from like the system clock or something like that, and you'll get different results every time. If you want to get the same result every time you put it in the same behavior pattern, exactly word for word, you need to fix a seed. Actual number of the seed doesn't really matter very much, but fixed seeds are important if you want reproducibility. So I'll just go over real quick here. The main format for OLAMA is the GGUF file, and you can download many of the major models in GGUF format. You can use Hugging Face to build into GGUF. If you have a safe tensors model that you found that you like, you can use Hugging Face to convert it to a GGUF, and then you build it from a model file in OLAMA. If you have a PyTorch model that you wanted to use, I'll let the slide speak for itself. Don't use pickles. Walk away. Everybody knows at this point that pickle models are a problem. Any model that you get from somebody who knows what they're doing and isn't malicious is going to be available in non-pickled formats. There's a couple of Python libraries for specifically making use of OLAMA within Python code, which is the kind of context that I would expect to most use OLAMA. I want to batch through. Now, I don't want to just read one clinician's note and batch it into ICD-10 codes. I want to read through 1,000 notes, leave my computer running overnight, parse through a giant chunk of these. So LangChain offers support for invoking, creating OLAMA instances and invoking them directly. And this will launch OLAMA on localhost. And it's basically very similar to running it from the console. You'll mostly use the invoke command or the generate command, but there's a full software developer scale array of tools for interacting with OLAMA and LangChain. It can be a little bit overwhelming if you are not a software developer. If you are not as comfortable with full-scale software development, but you do some coding, you work with some Python, you're not as concerned about, maybe working with a larger framework where you're manipulating the LLMs in the other ways, which you would with a LangChain library. There's a fairly small direct API-oriented library that just does the things that Ollama does. So it'll support the commands out of the Ollama API, and that's all it supports. And that makes learning it much easier. So if you're thinking like, hey, I want to call this in a Python script, I don't want to read through 20 pages of manual to figure out how to do that. This is more the choice for that. So just to recap before we get to question and answer time, model provenance matters. You want to treat this, it's a fairly large object. And there's a lot of ways to bury potentially malicious things in a large object, even if you're trying to containerize some. I would just go with models of known provenance. And if you want to customize it, do some customization of it yourself, mostly through prompt engineering. Prompt engineering will get you a long way. The difference in performance between a specialized model and a general purpose model is not that large right now. And when it does, there's probably going to be models from the major players that are somewhat specialized in the domain you're interested in. Also, be a little bit concerned about data provenance, because the pickle problem might not be only pickles. So just be aware that sometimes, in particular, just avoid pickles. I'm a big fan of open source software. It is a real boon to security, and especially so when the fundamental market force here puts that tension between customer and provider here. There is that fundamental conflict of interest, so you want open source models that are scrutinized. Containerization is a good practice. I recommend using Ollama. It has been gaining popularity rapidly for good reasons. It's not that it's the only option out there, but it's well built. It includes Docker. It does CPU support. It supports all the major models. It supports really a fairly high level of customization, including using your own model file that you have modified, that you fine-tuned in Hugging Face. And with that, we have a little while left for questions and discussion.
Thank you first. Questions about pickles, because you talked about this a lot and
Yes.
really interested in security. So you mentioned that the virtual machine is the most secure.
Yeah.
And then Docker is less secure, but more common, maybe more accessible. But then you also said that if you're using a virtual machine, the models that you're running will have Docker within them running under the hood. And so you still have that same.
If you're running Ollama is running Docker under the hood. If you're running a virtual machine, you can run Docker inside of the virtual machine as well.
So are you saying that Ollama does not run on a virtual machine? That's if you want to run it only on your local machine?
So a virtual machine will be on your local machine. So basically what it's doing is it provides a completely isolated emulation layer that runs an entire operating system on top of it. So if you imagine, say the movie Tron, if you're looking at things from the perspective of the program, if the program's in a virtual machine that runs Ubuntu, and the virtual machine is hosted on a Windows machine, the program running inside of the virtual machine only sees Ubuntu. It doesn't see anything at all. As far as it's concerned, like the stuff that it's showing in the window of the virtual machine is being piped directly to a monitor of some kind. So virtual machines completely isolate. They completely isolate what's inside of the virtual machine from your actual physical local machine. So the Docker is basically a lightweight partial virtual machine where it doesn't totally isolate. What's inside of it from what's outside. There's a little bit more of a connection. It's a narrower connection, but it's not 100% isolated.
I'm not sure. Was your question sort of really about like VMs versus Docker from a security perspective, or was it sort of different from that?
If we choose virtual machine, are we then protected from the Docker issues that you described? Or
if you run it on a virtual machine, you are pretty well protected from any security issues.
Yeah, so you could be. I mean, Thomas glossed over parts of this. We sort of just jumped right into the middle of parts of this. So like there was some assumption of like, great, you're fairly familiar with something like a VM, right? But like the virtual machine is like a software abstraction of a physical computer, right? So it's sort of like a software computer within a computer. But within the virtual machine, you have a huge amount of security configurability. So like you sort of have the option on a virtual machine of essentially like network isolating your entire environment within your physical computer, right? So you could configure it such that you essentially have what would seem like an air-gapped machine that you're running things on, but yeah, that's a whole other software process. So it's potentially not trivial to sort of, if you're not familiar with like installing and configuring, especially from a security perspective.
It's not something I would do. I would have to.
Yeah, I mean, so that's where, to his point, Docker is, rather than like, a whole computer, it's like a canned piece of software, right? So the idea is you could take it from one computer and to another, and it would run because it has enough stuff for it to run. Like increasingly, Docker is a really nice solution for something like R or Python. Because like on your computer, you have, who knows, Python 3.6, and I have 3.7, and we have a million different dependencies installed. But like we have to install, or we're trying to run the same program. So Docker is a way of like giving enough stuff for us to run the same program between computers, but it doesn't have all of the security configurability that a virtual machine has. But yeah, so like a virtual machine, like you can configure that to be completely locked down. So it would almost be irrelevant whether it's Docker or sort of like what you're running, but it comes with the overhead of like, can you install it? Can you configure it? Can you kind of do all those other pieces? So it's sort of a spectrum, right? Like and I should just probably for the record, openly say to be clear, like I would not view any of the things we're talking about here as a way to take what at UNC we would call like tier 3 data and just like run it into an LLM and start experimenting with it on your own. Like if you have use cases like that, you're gonna have to go through IRB, you're gonna have to go probably through ITS and lots of different ways, because like I'll even say like within the data science lab, like we're going through all of that kind of stuff to even consider using this on anything remotely sensitive. But yeah, it kind of gives you these different tiers of security and ease of use, right? So like virtual machine gives you lots of security, but less ease of use. Docker is pretty good security, less ease of use. But then you can use something like a pure executable like GPT for all or Llama file and just put that on your physical machine. But then it also has access to everything that's on your physical machine, has access to anything that the domain or the network that your machine is connected to. So I don't know, does that
Yeah, that answers my question.
Okay.
Yeah,
There's a long-winded answer.
thank you.
Yeah, and so one of the things that's the type of exploit that's gotten flagged on Hugging Face a lot is very specifically opening a remote shell with a connection to some distant IP address. So somebody in, say, Shenzhen now has access to the root of your computer. Now, if you try doing that in a virtual machine where the virtual machine has been told it has no internet connection, that's just not going to, that'll just bounce. And if it's inside of a Docker container, then the exploit will have needed to specifically have been designed to work to escape the Docker container and then do that. So, and some of this is also a layers issue. So if you were running Olama inside of a Docker container, then for an exploit to escape the model, the exploit would need to go through Olama's Docker container, then out the second Docker container, and then to your operating system. So in general, the virtual machine is your top security pick. But everything that you do that involves containerization will make it generally more secure. So we may not want to run an LLM on something that has tier 3 information stored on it. But if you're thinking about, hey, well, this is a relatively secure machine that I don't want to have compromised, you're probably fine just running Olama as is, provided that you're using models that are heavily scrutinized. I don't feel at all like I have a gaming laptop at home that I dearly love, right? I feel perfectly fine running Olama, Llama file on that. I'm a little bit leery of GPT for all because while it is, at least in principle, open source, the fact that it's opt out, send all your personal data, leaves me a little bit skeptical of whether or not that opt out will stick in the settings and not quietly reset itself.
Are there other questions
Yes.
before we go to chat?
Yeah, I got a quick one actually. So that was great. That was a really helpful breakdown. I had a question about hardware and kind of the local kind of LLMs. I've messed with those and, painfully slow, right? So you have any, I assume, it's mostly about GPU and kind of ramping that up. Do you have any considerations there around hardware specs to make it a little more usable?
Okay, so this is actually where we get into some of the stuff that I brushed by real quick. And one thing that I brushed by quick that's not on this, not related to what's on the slide is just model choice. And what I've found running on the potato over there or my work machine, which is slightly less of a potato, but nowhere near the performance of my gaming laptop, is that there's a huge difference in the speed of these different models. The different available models have hugely different speed based on their architecture. So some of these models are a lot more efficient than others. And because there are both memory limitations and processing speed limitations, it can get very nonlinear as far as on my machine, this is not a great model to use. Oh, well, it might run half as fast on a good machine, but on this machine, it's a 1/10 of the speed. So picking the right model and testing which models run how is helpful. There's also some stuff you can do in terms of the configuration of your model. And this is stuff that you can do in the OLAMA model file, where you're telling it how many sorts, what kind of resources to use. So it's entirely possible, like if you picked up and run, a basic local model, it may not be using the right kind of resources, or it may not be using enough of it just because of how it's been set up. Like if I wanted to actually run it really quickly on my gaming machine, I would get into the guts of the setting and make sure that it's correctly saying, I should actually use all this GPU power on this gaming machine. So you have switches that let you orient it towards GPU and CPU and that tell it how much it should use in terms of resources. And that will go a long way from the default speed.
Yeah, one of the sort of rules of thumb that I think someone told us was at baseline, you probably wouldn't expect for a model to even run unless you have like at least half the memory as parameters in the model. So like if you have 4 gigs of RAM, like you're probably not even gonna get more than an 8 billion parameter model to run. So if your goal is to locally run like an actual large enterprise 70 billion model, like
Yeah,
you
I
need
mean,
a machine big enough to have a lot of memory.
so, and that rule of 2, actually GPT-4 is demonstrating for us right now. I don't know if it's entirely visible, but I've opened the downloads page and here's this 4 gigabyte model. And it says, oh boy, you better have 8 gigs of available memory to run this. And your machine does not have 8 gigs available. It's got 7.87. Like I said, potato. But yeah, that there's definitely that memory sensitivity and picking those small language models helps a lot with it.
That's great, thanks.
So here's one question in the chat. So using the example of ICD-10 codes, would a person be able to run this model on notes downloaded or saved on a local drive? Or could this type of local model run on, say, like an entire electronic health record? This person says, full disclosure, I'm an MD with very little computer science background.
So in terms of running it on a batch, so there's sort of 2 different questions. One is the legal case of, in this particular situation, should I have these records on this computer running these programs? So if you've got tier 3 information and you're running it on your personal machine at the coffee shop, using something you downloaded off the internet, you might not want to be doing it in that environment. But
and let's just pause and make sure. So like basically any of the healthcare data that we're all talking about, like anything from Epic, anything from the UNC healthcare system, most of our identified research data, all by UNC ITS standards, falls into tier 3 data, which means you should probably not be using this on any type of large language model unless you have gone through like multiple rounds of review with various authorities at UNC to make sure like your system is set up correctly, you've obtained and configured your data correctly. So again, I just want to be really explicitly clear that like nobody, whether you're a physician or otherwise, should be finding ways to like try and extract notes data or other things and get it into an LLM without a lot of consultation with other people.
now, let's say that you do have the identified notes data, perhaps that you've gotten from somewhere that
Have a well thought out and designed research study that's been IRB approved and had
So,
an ITS
yes.
review and has been fully de-identified. Yep.
So you have your de-identified notes data, or a blank check from the lawyers. I know they don't cut blank checks very often, but see if I can get to the right slide without clicking too many times. So this is where I would talk about using really one of these Python libraries where you send it a query for a whole batch of files at once. So I would, so for example, with the lane chain library, the dot generate, you can stick a whole list of things into. But, with Olama Python, you can pipe files into this, run a quick for loop. File goes in, file goes out. If you're comfortable writing a quick for loop in Python, you can run through a whole list of files in a directory with Olama Python. Now, as far as that goes, it seems like it would be a common demand enough that somebody would have set up a quick Olama script for it, or it might be a nice thing to have as a command functionality for Olama. Go through this whole list of files and then put the output over in this directory. To my knowledge, that's not a feature there. You can probably find scripts where there are examples of it. But I would say that generally speaking, at this point in time, you should be comfortable with writing a Python for loop to go through and do some kind of batch processing like that.
Yeah, and I can maybe speak to the Epic side of things. So, as the healthcare system sort of moves more of their data warehousing and IT infrastructure into Microsoft Azure, I think that part of their strategy is to really have LLMs and other things like that in Azure available to use, at least for operational purposes. But I don't have a ton of insight into that, considering it's on the healthcare system side and within ISD. So we're really much more focused on research. And so from a research perspective, we wouldn't have anything that has access directly to Epic, the Epic system itself. So anything that we're talking about from a research perspective, they'd be things that we'd have to go through a data extraction process. So this is all stuff that we're getting from databases or other types of data systems, and then pulling into secure environments and then making it available to the localized LLMs. Whether those are notes or discrete data or claims data or whatever else.
And so something I will say is that whatever they do eventually plug into the health system, as I'm familiar with the nuts and bolts of what's going on, I expect that what gets plugged into the health system will be, in principle, actually less secure than running this on a virtual machine for somebody of my level of technical expertise. However, the legal responsibility side, if Microsoft is responsible for leaking our data, is extremely different than if I personally am responsible for leaking our data. So that's one of the governance and responsibility issues are very salient in the EHR world. And that does create difficulties.
Question.
So it says suppose I have a local LLM and I want it to answer a question specific to a URL or a web page. Is it possible to build a chatbot since the model is running locally and has not access to internet?
Yeah, so if I were to try to pipe a URL in to PowerShell, it would tell me, hey, that's not part of your file system. So using PowerShell specifically, when and let me just toggle over to that PowerShell and scroll up to show what I'm talking about. So up 3 here, where I said Olama, run phi3, and then I had this like quote, $cat, and I've got this file name. So the process that's feeding that text into phi3 that's in that file is the PowerShell. It's not the large language model itself reading it. The large language model only gets the data that goes in through its API. And it's the PowerShell itself that has access to the file system. So if I was on, say, a Linux box, I could like run a text-based browser, pipe the text of a website through that text-based browser out into a text stream that I then pipe into the model. But you're not going to be able to just point the model and say, hey, look up this thing on the web. When you're running that local model, it is not going to have internet access. Not any of the containerized small language models that we're talking about. If I ran into a model that advertised having that capability, I would not want to run it locally for privacy and security concerns. So that's a functionality that we don't necessarily want to see in the portable model space. All right, at least not from my perspective as a researcher. You might find it really convenient to have it on your phone for personal questions, but to my knowledge, the small language model market has not really oriented towards that. It's been looking at this containerized system.
Yeah, I don't see any other questions in the chat, so I think we're good.
Somebody asked about sharing contact information.
Yeah, so I followed up with that directly. Yeah.
Okay, guess that's everything.
All right.
All right, thanks everybody on the Zoom call for joining.
Thanks all. We will be back next month on the third Tuesday of the month at 12:30 with our next Data Science Lab seminar, where I'll be talking about an introduction to OMOP as a common data model and using it for research, as well as our resources for OMOP at UNC. Thanks all.